See, for complete characteristics of converter as a rectifier and inverter, for drawing the characteristics, we have to frame the rectifier equations and inverter equations. Once if you know the equations for rectifier and inverter, then only we can draw the complete characteristics. Without knowing the equations for rectifier and inverter, we can't draw the characteristics. So first I am framing the equations for rectifier. Let us take for rectifier, direct current is ID. ID, this is the formula, direct current, root 3 Vm by omega xs cos alpha minus cos alpha plus mu. Take root 3 Vm by omega xs as Is. Bring this Is to this side. That is ID by Is. That is equal to cos alpha minus cos alpha plus mu. Let it be equation 1. Now come to second equation, output voltage. This is the output DC voltage. This is the output DC current. This is output DC voltage. Vd is equal to Vd naught by 2 cos alpha plus mu. Already had discussed this formula. Now bring this Vd naught to the left hand side. Vd by Vd naught. Vd by Vd naught is equal to cos alpha plus mu by 2. Now from the inverter waveform, already had discussed the inverter waveform. From the inverter waveform, we are having alpha plus mu is equal to pi minus gamma. Pi minus gamma. Why I want this equation means I want to convert equation 1 and 2 in terms of gamma, not in terms of alpha, not in terms of alpha. And okay. Now expressing ID and ED in terms of extinction angle. See first equation. In the first equation, keep alpha as it is. Keep alpha as it is. In place of alpha plus mu, what we can substitute? In place of alpha plus mu, here this is they have given wrong. Here it should be cos alpha plus mu. They have given wrong. Change it in your textbook also. This is cos alpha minus cos alpha plus mu. Cos is missing here. Here cos is missing. Write down cos. In place of alpha plus mu, substitute pi minus gamma. What is the value of cos of pi minus gamma? Cos of pi minus gamma. What is the value? What is cos of pi minus gamma?
Cos gamma.
Minus cos gamma.
Cos
Then it will
gamma.
become minus of minus plus. In the first equation, ID bar is equal to cos alpha plus cos gamma. Because cos of pi minus gamma is minus cos gamma. Minus of minus, it will become plus gamma. Therefore, we have got the first equation in terms of alpha and gamma. First equation you are getting in terms of both alpha and also gamma. Rectifier is controlled with alpha, gamma is controlled, inverter is controlled with gamma. Now come to second equation, Vd bar. Vd bar is equal to cos alpha plus cos of pi minus gamma. That will be minus cos gamma. See, minus cos gamma in this equation. Minus cos gamma divided by 2. So let it be equation 3 and equation 4. If you want to write in your notes, you can represent the equations in your notes. Let it be equation 3 and let it be equation 4. Is it okay now? Now this is equation 1, it is equation 2, it is equation 3, it is equation 4. This is condition. Note down this one as condition. Alpha plus mu is equal to pi minus gamma. Now what I want? Now what I am doing is I am eliminating cos gamma in our expression. How cos gamma is eliminated in this? We have to eliminate cos gamma. In this from these two equations, I want to eliminate cos gamma. How will eliminate cos gamma? Bring this 2 to this side. Add equation 1 and bring this 2 to this side. Bring this 2 to this side. 2 Vd. This is ID plus add these two. Then cos gamma plus cos gamma minus cos gamma will be cancelled. Plus cos gamma and minus cos gamma will be cancelled. If 2 is bringing to this side, ID plus 2 Vd. ID plus 2 Vd is equal to cos alpha plus cos alpha. It will be 2 cos alpha. Suppose if you want to okay, net has been disconnected. Once again, I'm sharing the screen. Screen is visible? Is screen visible? Hello?
Yes, sir.
Is screen visible? This equation is visible? Anyone?
Yes, sir. Yes, sir.
Yes, sir.
Okay. See here, we have considered this is equation 1, this is equation 2. Now, after substituting the condition in equation 1 and 2, we will get equation 3 and 4. This is equation 3, this will be equation 4. Now here, bring this 2 to this side, 2VD. Now, if you want to eliminate cos gamma, add these two equations, equation 3 and 4. We'll get this equation. Now, if you want to eliminate cos alpha, equation 2, equation 3, equation 4 minus 1. Equation 4 is 2VD minus ID. Equation 4 minus 3. 2VD minus ID. Okay. Then we'll get minus 2 gamma. Here it will be cos alpha minus cos alpha. Both are going to be cancelled because we are equation taking 4 minus 3. Minus means cos alpha minus this. Minus cos gamma minus cos gamma. That is minus 2 cos gamma. Now we got the expressions. Let it be equation 5 and 6. This is 3 and 4. This is 5 and 6. Now to the next equation. Now I want VD from this. VD is equal to cos alpha. Okay. Divide the entire equation with 2. This is ID by 2 plus VD, that is equal to cos alpha. Therefore, if I want VD, bring this minus ID by 2 to this side. That is cos alpha minus half ID. Let it be equation number 7. Let it be equation number 7. From equation 5, we'll get this equation. From equation 6, we'll get this equation. Up to here, any doubt? What I have done is, I have brought the equations in terms of VD and ID. See, VD and ID. First, this equation is in terms of alpha, rectifier. Second equation is also in terms of VD and ID, but this equation in terms of gamma. Up to here, clear? If any doubt you are having, you can ask me. Nothing I have done. This is of the form y is equal to mx plus c. Y is x-axis, y-axis. On x-axis, I am taking ID. What is the slope? Minus of. Y is equal to mx plus c. What is the y-intercept? Cos alpha. Similarly, here also, y is equal to mx plus c. Here slope is minus of. For gamma, y-intercept is minus. For invert, so this equation is of rectifier. This equation is of inverter. Rectifier is controlled with the help of alpha. Inverter is controlled with the help of gamma. Now I will draw the characteristics of converter. Converter means rectifier and inverter. This equation is a rectifier. This equation is inverter. From these two equations, I will draw these characteristics. So once again, you see, once again I am explaining. Complete characteristics of converter as rectifier and inverter. In exam, see the syllabus where it is. I am showing the syllabus. So converters control characteristics. This topic they last for 5 marks. Converters control characteristics. What we had to write in exam. This thing we had to write in the exam. Characteristics of converter as rectifier and inverter. First, this is the equation 1. Note down if you want. ID bar is equal to ID by S. This is equation 1. This is equation 2. This is equation 1. Equation 3.43 is equation 2. Equation 3.43 is equation 2. Then this is condition. From the waveform we have got this condition. Note down this is condition. Next, from equation 1 and 2, if you substitute this condition in equation 1 and 2, substitute this condition in equation 1 and 2, we will get equation 3 and 4. Now bring this 2 to this side, 2VD. Add equation 3 and 4, you will get this. Subtract equation 4 minus 3, you will get this equation. Now this equation is completely alpha. This equation is completely gamma. What we have done, we have eliminated overlapping angle. from the above equations. Now if you from this equation we'll get this equation, from this equation we'll get this equation. This equation is rectifier equation, this equation is inverter equation. Now write down here y is equal to, this is mx, x means id. See, on x-axis they are taking id. Y is equal to mx plus c. Y intercept is plus cos alpha from the rectifier equation. Now see the inverter equation. Vd bar is equal to, y is equal to mx plus c. Here the slope is minus. For both rectifier and inverter, slope is minus. Here also the slope is minus 0.5. Here also slope is minus 0.5. This is the falling slope because minus is there. Then cos alpha is plus, cos gamma is minus. For rectifier, y-intercept is plus. For inverter, it is minus. Now see the characteristics how we are drawing. First I am taking rectifier equation. This characteristic is for rectifier. Next, this characteristic is for inverter. How they are drawing this rectifier characteristic, you see. Y, Vd bar on y-axis, Id bar on the x-axis, y-intercept cos alpha. Let us take initially alpha is 0. What is cos 0? What is cos 0?
1.
What is cos 0? Anyone?
1, sir.
1. Okay. Here it is 1. Cos 0 is 1. Alpha, when alpha is 0, cos 0 is 1. From 1 onwards, what is the y-intercept now? 1. Now from 1 minute. See here, from 1 onwards it is falling. So what is the slope now? Minus 0.5. Minus means it is falling, the falling slope. Next take alpha is equal to 60. What is cos 60? What is cos 60?
1 by 2.
1 by 2 means 0.5. See, from 0.5 is the y-intercept now. 0.5 is y-intercept. Alpha is 60. It is falling with the slope of minus, which is falling with the slope of half. Okay, same, so parallel, all are parallel because slope is same. Next take cos 90. Cos 90 is 0. See, cos 90 is 0. Slope is minus 0.5. All are parallel lines because with the same slope all are having. Next cos 120 is minus 0.5. Cos 150. Cos 150 is this is not 150. This is 180. Cos 180. Sorry, they have given wrong here. Cos 180 is minus 1. Cos 180 is minus 1. So change it as 180. They have given wrong in your textbook. It is minus, sorry, alpha is 180. It is falling with the slope. Any doubt in this rectifier characteristic? From this equation, you have drawn this characteristic, rectifier characteristic. Rectifier is also one converter. Next, we will go for the next converter, that is inverter. The inverter is cos gamma. Here, what is 0? Cos gamma, let us take 0. What is cos 0? 1. But here minus is there. So your characteristic will start here, minus 1. And the slope is negative. Slope is negative. From the negative side, if you are going negative, minus of minus, it will become positive slope. So it is going in this direction. Next cos 60 is 0.5, but minus is there. From minus 5 is started. Why they are taking positive slope here? But here we are having minus. Why they are taking a positive slope? Because if we take minus common, if we take minus common, take minus common here, then you will get cos gamma plus half id. Bring this minus to this side. Minus vd means inverter, plus vd means rectifier. Here they are taking minus common, then it will become here minus, both are plus. That's why negative voltage. From negative side, you'll start the voltage and it will be the positive slope. Cos 90 is 0. Cos 120 is minus 1. Cos 180 is minus of minus plus 1. That is about the inverter characteristic. In exam, what you have tried is, if they ask converter character, sorry, page number 94, characteristics of converter as rectifier and inverter. This first equation, second equation, then condition. For eliminating mu, we are substituting this. For eliminating mu in the first equation, second equation, we are substituting this. Then automatically mu will be eliminated. Now equation 3 and 4 is independent of mu. After that, add these two equations and subtract these two equations, we will get these equations. From these two equations, we are framing y is equal to mx plus c. First equation is in terms of alpha rectifier. Second equation is in terms of gamma. From the first equation, we will draw the rectifier characteristics, and second equation, we will draw the inverter characteristic. In exam, up to here, you draw y-axis Vd, x-axis Id. Any doubt in the characteristics? So today what we have done is, today we have discussed the characteristics, converter control characteristics we have discussed. Page number 94, you not done this. Tomorrow you'll see VDCOL, voltage dependent current order limit. With that I will complete the second unit. Reactive power anyway, Naresh sir will explain in third unit in facts. Already we have completed unit 4 and 5 also. We will go for the revision of this. Before going for the revision of 4 and 5, for class test, 1, that is mid exam 1, unit 1 and unit 2 up to here, I'll give in the mid. And also, okay, from the first two units only, mid exam will be there. Even though I have completed unit 4 and 5, I won't give questions on this for unit 4 and 5. Only from the first two units only I'll give the questions in mid exam 1. And these questions, from where I will give? Unit 1 and unit 2 mid exam, where I will give the questions means, in your Kamakshaya textbook, at backside multiple choice is there. For chapter, uh, I will show where it is. See, in your chapter 3, behind chapter 3, multiple choice is there. I'll tell the page numbers. This one, page number 126, multiple choice questions. Page number 126, 127, 20 questions are there. Page number 126 and 127. Next in chapter 4 also, multiple choice is there. Chapter 4. Okay. Page number 172 and 173. Page number 172 and 173. Okay. 126, 127, 172, 173. Even chapter 4. Okay, page number 195. Chapter 4 also I have given. Page number 195. Okay, page number 195. These 50 questions, multiple choice questions you read. Page number 126, 127, 172, 173. Next, page number 195 and 196. Total 50 questions I am giving. Out of these 50 questions, you will get 20 questions. Okay, in the mid one exam. Read these things. Wait for a minute, I will take the attendance.